My name is Willie Hardy. I'm Vice President of Database Product Marketing at Oracle Corporation. Today we're going to talk about database partitioning. Database partitioning gives us the ability to take our very large tables and divide or partition up into smaller, more manageable pieces. The reason we need to think about database partitioning is that databases that support our transaction processing and our data warehousing systems are trebling in size on average every 2 years. This means a 500 gigabyte database or half a terabyte database back in 2001 has grown to 1.5 terabytes by 2003, 4.5 terabytes by 2005, and will be over 13.5 terabytes by the year 2007. So this gives us a big challenge in terms of managing our users' performance and availability expectations. Let's say we have a large sales order table that's spread across 4 individual disks. This table typically contains millions of rows. Now the challenge we have with large tables like this is all our operations take place at the table level. We do queries at the table level. We do index builds at the table level. We do data loads at the table level, which means that as we add more rows into this large table, performance and availability can tail off. If we were to lose one of the disks that supports this table, we would lose the entire table. Our system's down while we try and repair that failure. A better solution is to take our sales order table, and by issuing a simple alter table command, we can partition our large table. And we can partition it based on a range of values, such as date or time. We can partition it on a list of values, such as country, region, or product. Or we can partition it based on a hashing algorithm on a partition key. So in our example, we're going to take our sales order table and we're going to partition it up into 4 quarters. So any rows that were in January, for example, are going to appear in quarter 1. Any rows that appeared in, say, the month of April are going to appear in quarter 2. We're going to insert similarly rows into quarters 3 and into quarters 4. Now, what we are able to do by partitioning this large table is, instead of having this large table spread across those 4 disks, we've now got individual partitions that have each got their own disks. So the advantage we've got in terms of query performance is, if we need to retrieve rows from quarter 1, we don't do this full table scan or full index scan anymore. We go straight into the partition that contains the data we're after. Now, in terms of providing higher availability, if we were to lose one of the disks that supports one of our partitions, all we actually lose is access to that partition, in this case quarter 2. We can continue to do inserts, updates and deletes to all our other partitions. So by issuing a simple alter table command to partition our large transactional tables, we can improve the performance of our systems, we can increase the availability of our systems, and we can ease the complexity of managing very large databases.